Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Today I try to explain for you how we deal with the bar which contain or which has dynamic force. Let us see this mechanism. They said find the torque, alright? But don't care about the direction of this torque. So how we deal with this mechanism? Let us give you a brief background. In dynamic force analysis, sorry for my handwriting because my stylus pen is so bad. We must, or you must, or we must know two things: acceleration polygon. Two, why I said must, because without them you cannot continue your solving the problem. So you must know them. So acceleration polygon and static force analysis. And we will use the graphical method to solving. For acceleration polygon, you must know how to draw velocity polygon. Alright? Alright. Before I continue, in the static force, if you see any example, let me try change the color. If you see any example, for example this 4x mechanism, they put some forces here, and you analyzes your system due to these two forces in the static. But in this example, which is dynamic force, no force there. So from where the force become? From the center of or centroid of the bar or of the link. So the force said equal minus mass multiplied by gravity, or acceleration of the centroid, acceleration of the centroid, and our moment equal minus moment of inertia multiplied by angular acceleration. Alright, in this example, the mass 1 given and moment of inertia for the first one given. I will not write it because we will not use it to save the time. Moment of mass of the two given by 0.2 kilogram. Alright, and moment of inertia for the two given by how much? 400 kilogram millimeter square, and mass of a 3 given for the link number 3, 0.3, and the moment of inertia for the 3 given by 20, same unit. Alright? What we'll do now, I said if you want to solve dynamic force, you must draw acceleration polygon. So because I don't have the perfect pen, so I cannot draw it for you. And second thing, our topic it is not how to draw the acceleration polygon. I will put the answer directly here. So this is how the acceleration polygon is. This is the normal for the link 3, and this is the tangential. Alright, from O to this point up to this point, which is our C. Which link? Link number 3. How we know? If I come to here, so the normal, then tangential depends where to locate. You must go and see. There is hundreds of videos explain this topic. Okay. So this is now our link 2 from O to what to C, and our link 3 it is from B to C or C to B. Never mind. All right. So what is our link to B to C? This is our link 2. And where is our link 3? O to C. So this is our link 3. So let me reset this. So what we have said that our force equal what? Minus mass multiplied by what? Acceleration of the what? Of the centroid. Alright. So from where I take this value, the acceleration of the centroid, you come from the first point up to what end? That means you take what? Your resultant. Alright? Here. For the link number 3. This is all the triangle for the link number 3. Alright? Since our link number 2, this is our link number 2, and this is link number 3, which is something like that. Alright. Since the center of gravity it will be in the middle, alright, in the two questions, alright, we come to velocity diagram, and what? We take the half of the what? We come to acceleration diagram, and we take half of the distance. So this is what will be our magnitude AG2, or sorry, AG3. And 2, no, 2 there is what? I cannot what take this half the distance here. I said, actually this is my resultant, and I take the half of it, half of the resultant. No. You must start from O up to middle. Alright? So, for, I will write this information. For A, G, take it from where? From O. Alright? There is some examples. If they give you a link like that, but the centroid, it will not be the centroid not in the center. For example, at some distance here. Alright, this is OB. Alright, or OC, like this example. I call it OC. Okay. So what we'll do here, you know that acceleration for the what of the C, the resultant, and you know its length, or its length for the OC, and you want to find what O, or acceleration for the centroid. Alright, divide by the distance. How much is the distance? We call it O to G. By that you can what? Find AG. Alright. So I will give you the, before continue, because I want to explain something else for you. Let me clear that. There's too much things. Sorry for the time. Alright. As we have said, the force, what is equal? Minus mass multiplied by acceleration of the centroid, and moment equal minus moment of inertia multiplied by angular acceleration. Right? So how we what find the direction? Direction for the force, we know the direction for the what? Center of of the acceleration of the what centroid. So it will be what the force in the opposite direction. This is F3. And same principle for the what F, F, F for the 2. They are not parallel to each other. There is some angle between them. Alright, you must what measure that. And for what? For angular acceleration, what I should do? Let me go a little bit to acceleration polygon. If I have what? Again, this 4-bar mechanism, and I said I will exponent for the number 3, so it will be same principle for the number 2. How we what? How we find the direction for the what? For the alpha. The direction of the alpha, this is normal acceleration, this is tangential. It will be what? If I take it, this my pivot, so it will be what? The tangential, it gives me what? Counterclockwise. Right or not? Sorry. Counterclockwise. So the direction for the alpha, it will be what? It will be clockwise. Clockwise. So this long story, I will give to you a brief and very easy thing. By this minus, you direct take what? This direction. So again, what we have said, when I draw the acceleration here for this part, I draw it what? Alpha, which is what? As we have said, it will be what? Because this is in this direction, we take it what? Clockwise, yeah? But by moment, this is alpha. Sorry for handwriting. Moment, it will be what? Opposite direction. Alright? So that when we directly taken by what? By the direction of the what? A tangential using the pivot. Same principle for the number 2. It will be what? Here. So, acceleration. Let me change the color. Acceleration. Or angular acceleration for the 2 and angular acceleration for the 3, what? Must know the direction of them. For the 2 it is clockwise, for the 3 it is counter clockwise. Right, I will give you the magnitudes for the AG2 given by what? 235,000 millimeter over second square. Alpha 2 given 520 rad per second. AG for number 3 given by what? 100,000. Alright, 100,000, and same unit for that. And alpha 3 given by what? 274 rad per second to save the time. Alright, and we have said this is what? This is clockwise, and this is what? Counterclockwise. Let me go to the very important concept. We will what? Calculate the offset. Offset equal what? Magnitude or absolute of the what? Moment over what? Absolute of the force. If you put minus or you didn't put the minus, what happens? Sorry for that. Yeah. If you put a minus or you didn't put minus, it will not change anything. Alpha. Moment of inertia multiplied by alpha multiply mass AG. Alright. So if I calculate for the 2 and I calculate for the 3, it's given substituting only. You have moment, you have alpha, you have mass, you have everything here. Substituting for the 2, you'll get 4.43 millimeter and 9.13 millimeter. Alright. And if I calculate the force, never mind if you put in minus or not, you know it is what? Mass G2, you know the magnitude, it will give you what? 47000. I will take it 47 for the what? Decrease the scale, and will be easier for the drawing. For the 3, it's given me what? 30,000. I will give it what? I will put it 30 Newton. Alright, by that, and I said never mind by never care or never bother with the minus. Why? Because what I said, the minus gave us the opposite direction of the what? Of the AG. So let me continue. So since you do that, let us come to link number 2. Link number 2. Oh, sorry, this is link number 2. Yeah, correct. And link number 3. Never mind with what? The drawing. I know it is so bad. Right. It is so bad. I will draw it as a line. It will be what? Better. It will be more clear. Right. If I draw this is as a line, this is as a line, and I know the centroid here, and this will be centroid here. Alright. If I come to my force, which I found it will be at that direction, yeah, correct? If I want to move it to here, why I move it to here? Because I have moment there. Why we found the moment? For this principle. And why I found the edge? Also this principle. So where I move it, to right or to left? It depends. For the length 2, what we have said for the alpha 2, it's in the what? Counter or clockwise, sorry. And for the alpha 3, we said it is counterclockwise. Correct or not? Alright. So when I come to F2, and I want to give me some torque or some moment, and moment it equal what? Force multiplied by h, or moment of inertia alpha. But here we will use that's principle. Right? We found the force and we found the h. But what is the direction? Here the alpha, it is what? Clockwise. So if I bring the force here, it gives me what? Clockwise moment. Alright? So the summary for that. The force will be here, F2, and this what will be our distance H2, which we have found it. Same principle. If I what? Bring my F3 here, where I should what? Bring it up. Why I bring it up? Because our moment, it is what? Clockwise. Our moment, it is what? Counterclockwise at link 3. So it gives me what? Moment like that. I take this my pivot, and this is my force, and you know that rule from what? Previous mechanism or mechanics materials. Alright? Since you do that, your answer will be what? About 80% solved. Alright? So let us come to here. We have said we'll put our force here with some offset, which is H2, F2, and we put our force here. Sorry, not about the center. Let me clear that. We put it here, F3, with some what distance, which is what? H3. You what? Move along the line. Right? You move along the line or along the link. By doing that, you will solve this problem as what? As a static problem. or static analysis, right? Using what? A graphical method. Why we put what H? Because H what will affect on the what? The intersect of the lines. If I shift it here, or I shift it here, I shift it far away, the distance which they what intersect, which we will use it in the what? In the superposition, or in the dealing with what? With the analysis of what? A force in the graphical method. Alright, we will, you know how to solve it. There is what? Thousands of the videos on the YouTube. You can what? Watch them. Anyway, I have solved it, and I found that solution approximately give me what? How much? Give me minus 484.848. Alright, 848 Newton millimeter. Alright, but the book has solved this problem, and he what solved it, and he found that minus 581. The minus means what? It is counter, or sorry, clockwise. If you remove that minus, you said 848 clockwise. If you put it what? If you put it, no need to write it clockwise. I will put the solution for the book. This is what? How the graph will be what? After we what? Putting the force, as we have said, don't care about that torque. This is what said found either in this direction or this direction. This is what? This is assumption. And the second thing, don't care about this number. This is what? Part of solution. We solve that problem because we have two forces. We solve it as what? Superposition method. I have what? The solution, sorry, it is what? It is black. This is our solution. It will be at final. Alright? Thank you for watching. See you guys.